Okay, welcome to this video on quadratics. In this video we're going to solve quadratic equations equal to 0. Now you should have watched the other videos in terms of factorising before you watch this one, because we're going to use factorising to solve these type of equations. Just a wee quick summary of what I expect you to know already. Any quadratic equation has this form: ax squared plus bx plus c. Okay, so any quadratic equation can be written like that, and we're going to solve this quadratic equation, or this type of quadratic equation, equal to 0, and that has a special formula or a special name. When we solve it equal to 0, we're finding things called the roots, where it crosses the x-axis. Now if a is positive, then every quadratic with a positive a, or a positive x squared, will have this format, a smiley face. It might cross the x-axis, it might not, and it might just touch it. But that's what it looks like. It has that sort of shape, a sort of U shape, symmetrical. And equal to 0, and if we can find the roots, it's telling us where it crosses the x-axis, which is the horizontal axis obviously, vertical is the y-axis. So in this case, this one would have two roots. This one here would only have a repeated roots called, okay? It's two roots, but they're exactly the same value, so essentially it just touches the x-axis. And this one up here doesn't have any roots, so we can't solve that. It wouldn't solve. So all the ones we're going to do, obviously, since we're trying to solve them to find where it crosses the x-axis, ours will all be of the type that either crosses the x-axis or it just touches it. Now that's for a positive a here, so a greater than 0. If a is less than 0, then what we get is like a sad face. It goes that way, upside down, it flips in the x-axis. So roots are still here. We might get it just touches, so it'll be a repeated root there. Or we might get one just doesn't touch the x-axis at all, and again that's one that we can't solve. That there's no solution to it, no real solution to it. Okay, so keep in mind when we're solving these things up here, we've got a wee picture like this, and where it crosses the x-axis is the values that we're actually solving using this. Okay, so here we go. The techniques that you should know for factorising: take out a common factor, difference of two squares, and the trinomial. So I'll be going over all the different types here as we go. So let's look at the first one here. Well, first thing I would do here, quadratic, let's try and factorise it. So first thing, take out a common factor. We've got x here. So if I take x out, then we can use the grid method. Actually, just before we take it out, let's use the grid method just to show you. You should be familiar with this if you watched other videos. Take out a common factor. A common factor is x. Something times x gives me x squared, so that's going to be x. X times something gives me negative 2x, so negative 2. So factorising, we get x bracket, x minus 2, close bracket, equal to 0. Now remember what we've done there. We've changed an addition or subtraction type sum into a product, which is a times sum. Something times something else. Okay, product sum, and that helps us very easily to work out values equal to 0, because to get 0, either x must be 0, because 0 times this bracket would give me 0, or if x is not 0, this in here, if that's 0, then 0 times x will give me 0. So there's possibly two values. So we have either x equal to 0, or the bracket, which is x minus 2, must be equal to 0. And obviously that's already solved, that's x equal to 0. And to solve this one, very simple, first year work, add 2 to both sides. So x is equal to 2, that's another solution. And you can put them in, 2 take away 2 is 0, 0 times x gives me 0. Or if x is 0, 0 times that gives me 0. Now what does that look like in terms of a wee picture? Well, We can see right at the beginning, x squared, that's a positive 1 x squared, therefore it's a smiley face. We know we've just solved it, the x-axis, so that's x equal to 0 and x equal to 2, therefore it's a U-type shape, and there's our values 0 and 2. Done, finished. Okay, so the root, x equal to 2, x equal to 0. That one done. Let's look at the one on the right hand side. Start with, can we take a common factor? Yes, we can. So we'll just do the grid method. We'll take our time with it. But I would expect you to be able to do that without using the grid at this stage if you've practiced this a lot. Well, 12 and 60. Oh, we can take 12 out for the numbers. And we have a t in common, so we can take that out. So 12t times something gives me 12t squared, well that obviously got to be t. 12t times something gives me 60t, oh that must be 5, 5 12s are 60. There you go, we'll factorise it, 12t bracket t plus 5 equal to 0. So again, we've changed it into a product, that's why we factorise, and we can now easily solve equal to 0. So either 12t is equal to 0, or the bracket must be equal to 0. So what have we got then? Well, 12t equal to 0, divide through by 12. 0 divided by anything is 0, so t is equal to 0. That's my first root. And my second one, subtract 5 from both sides, so t is equal to -5. So if we draw a wee picture again, this is our second root. So we picture back to what we started with. Well, that's 12t squared, so that's a positive 12, so we have a smiley face. T equal to 0, t equal to -5. So we have a happy face because it's a positive x squared, so it was something like that. Okay, so those two equations were to do with taking out a common factor. Now, that's the easy ones. Other ones can be a wee bit harder. So let's look at something a wee bit different. Let's look at something like this. X squared minus 9 equal to 0. And I'll just put another one over here at the time, so we can do two of the same sort of type all at the same time. So the other one would be 100 t squared minus, can we make that? Can we make that 4t, something like that? And see what we get there. Oh, sorry, no, we won't make that. We'll make it 4. We'll make that 4 equal to 0. So what do we get there? To get a common factor, well, we don't have a common factor, so we can't take a common factor. So the next bit in your factorisation, the second thing in order is difference of two squares. Is that a difference of two squares? Yes, it is, because that's a square term and that's a square term, and it's the difference between them. So without any working at all, we just write down x plus 3, x minus 3 equal to 0. So we can now just solve that. So either x plus 3 is equal to 0, or x minus 3 is equal to 0. So x is equal to -3, or x is equal to 3. That's me adding 3 to both sides there, in case you're not sure. And that's me subtracting 3 from both sides if I'm not sure. So there's one of my roots, and my other root. And that's always the sort of case when it's a difference of two squares there. So let's draw a wee picture. Again, it's a positive x squared, so one root's at -3, the other root is at 3, and it's a positive, so it's a happy face. It's a U shape like that. Okay, let's try this one. Again, can we take out a common factor? Yeah, I think we can. We can take 4 out as a common factor, so let's take 4 out. So 4 comes out, And well, again, let's do the good method just in case you've not watched other videos. So 100 t squared minus 4. So taking 4 out as a common factor, well, 4 what gives me 100 t squared. Well, that's going to be 25 t squared, and 4 times negative 1 will give me negative 4. So factorising that, I've got 25 t squared minus 1 equal to 0. So we had to factorise this one at the start because we had 4 in common. Let's check the bracket. Second step is it a difference to 2 squares? Yes, it is. 25 is a square number, t squared is obviously squared, and 1 is a square number. So without any working, we can write down 5t minus 1, 5t plus 1 equal to 0. So we have to solve that. Either the bracket is equal to 0 or this bracket is equal to 0. 4, we can't do anything with 4. 4 will never be 0 because 4 is 4. So it's only to do with 2 brackets, so we don't really need the 4. So it's 5t minus 1 must be equal to 0, or 5t plus 1 must be equal to 0. So solving that gives me 5t then is equal to 1, divide through by 5. So in this case t is equal to a fifth. And the same idea here, 5t is equal to minus 1, divide through by 5. So t is equal to minus 1/5. Let's draw a wee picture, just put it over here, a bit of space. Back to our original, again that's a positive, it's 100t squared, so it's going to be a happy face. Let's put a fifth here, minus a fifth here, and it's a happy face, so it goes something like that. Okay, so that's the difference of 2 squares, difference of 2 square method for solving quadratic equations there. And the next one we're going to do is we'll do the trinomial version of it. Okay, so that's why you learned how to factorise. It was all aimed to do what we're just doing here. So just going to look at the trinomial version. So I'm just going to look at a question and get a decent question for it. Yeah, here we go. Right, here's a couple here. Again, I'll just do 2 because they're all done the same way, so no point in labouring the point too much. So x squared plus 3x plus 2 equal to 0, and 3x squared minus 11x minus 4 equal to 0. So again, we factorise so we can find the roots. So we'll try to find where it crosses the x-axis. So can we take a common factor? No, we can't. There's no common factor there. Can we take out the difference of 2 squares? No, we can't, because there's 3 terms. Difference of 2 squares, there's only 2 terms. So actually no thinking in that, because there's 3 terms, so you just discard the difference of 2 squares right away. So it's the trinomial method. So remember what we do, x squared here, 2 bottom right. We need 2 numbers that are going to multiply to give me the AC, which is 2. Remember, I'm assuming that you've already watched other videos, so this should be all easy for you, or you should know how to do this already. So that's your AC that you're multiplying together to get the 2. And at the same time, we must add to give me 3, which is the B term in the middle. And it's a positive 3. So factors of 2. Well, factors of 2 is just 1 and 2. So 1 times 2 is 2, 1 plus 2 is 3, so it works right away. And remember, it's not really 1 and 2 we want, because the middle term's in x's, so it's x plus 2x, so these are the 2 terms that we really want, and that equals 3x, which is the middle term. So where do we put it? Doesn't matter. X in there, and that's a positive 2, and the other one positive 2x. So to get a common factor for the top one, x. Take out the common factor for the bottom one. Well, we don't seem to have a common factor, but there is always a common factor. 1 is always common to any number or letter, so we can take 1 out. It's a positive 1, so that's one of our brackets. Second bracket, well, what's that going to be? Well, that's going to be whatever comes up here. X times something must give me x squared, so that's x. X times something must give me 2x, so that must be 2. So we have x plus 1, x plus 2 equal to 0. So either that's equal to 0 or that equals to 0. So let's solve it. So x plus 1 equal to 0 and x plus 2 equal to 0. Just remember, if that's 0, 0 times that gives me 0. Or if that's 0, 0 times that gives me 0. So that gives me x equal to minus 1 and x equal to minus 2. So we sketch that one. Back to the beginning, x squared is a positive, so it's a smiley face again. So we've got minus 1 here, minus 2. Remember, this is where it crosses the x-axis, and it's a smiley face. So there we go. That's that one solved. Right, let's look at this one. This is a wee harder, obviously, with the coefficient of x squared equal to 3. So that makes it a wee bit harder. But it's the same technique. So let's put the grid. 3x squared here and minus 4 down here. We need two numbers that multiply together to give me AC. Well, AC is going to be 3 times negative 4, which is negative 12. And at the same time, the same two numbers must add to give me negative 11. Oh, right, okay, so factors of 12. 1 and 12, 2 and 6, 3 and 4. Now, when we add them together, we need to get negative 12. So, hopefully, you can see that it must be 1 and 12, and we make, we make negative 12 rather than positive 12, because 1 plus negative 12 gives me negative 11. 1 times negative 12 gives me negative 12. So it must be 1 and negative 12. 1, negative 12. And again, it's because of the middle term, we really want a positive x plus a negative 12x, and that gives me negative 11x. So these are the two values that we want. So I'm going to put my x here and my negative 12x here. Again, it doesn't matter where you put them, you can swap them around if you like. So top bit, take a common factor out. Well, that's going to be 3x. And take a common factor of this one. Again, nothing seems to be common, so it must be a positive one. So something times that gives me 3x squared. That must be x. 3x times something must give me negative 12x, so that must be negative 4. So that's for two brackets. So we've factorised it into 3x plus 1, x minus 4, equal to 0. So either that bracket is 0 or that bracket is 0. So let's solve it. X plus 1 equal to 0 or x minus 4 equal to 0. Just solve this one first, it's easier. So add 4 to both sides. X equal to 4. So that's easy, that one. There's the root. Just put the roots in here. Always like to box them so for the examiner I can see exactly what the roots are. This one here, subtract 1 from both sides. So 3x is equal to minus 1. Divide through by 3. X is equal to negative 1/3. So let's sketch it. Back to the original, again, smiley face. And the roots are negative 1/3, so that's just about, say, about here. Then we've got 4, but 4 will be quite a bit further over here. So that's 4, and we have a smiley face. Okay. That's meant to be smooth, that's a U shape. Okay, and that's how you solve quadratic equation by factorising. Now the next video that I'm going to do, Well, we can't always factorise quadratic equations. Sometimes we don't factorise. And what do we do when they don't factorise? Well, we'll discuss that in the next video. Want to practice this? Go to mastervision.com, National 5, Factorisation, and you'll see plenty of wee sheets in there on how to factorise. Okay.